The A question asked us to find an equation for the plane which contains these 3 points, P, Q, R. So in order to do that, we're going to need a normal vector. And in order to get that, we need to come up with the cross product of 2 vectors based on these points. Now, while we could create, any 2 vectors in order to come up with the normal vector, the C question is asking for the angle between PQ and PR. So we'll go ahead and use those 2 vectors. Because we're going to need them for the C part. So let's come up with P, Q, P, R, and so we've got 4 minus 4 is 0. Negative 4 minus 4 is negative 8. And 7 minus negative 1 is positive 8. That gives us our PQ vector. And our PR vector is 8 minus 4 gives us 4. 0 minus 4 gives us negative 4. Finally, negative 1 minus a negative 1 gives us 0. So that gives us our 2 vectors. Now to come up with our normal vector, we need the cross product of PQ crossed with PR. So now to do our cross product table here, we've got I, J, K, I, 0, negative 8, positive 8, 4, negative 4, and 0. So we're going to have down here, we'll have I minus J and plus K. So to begin with our I, we've got 0 minus a negative 32. So that gives us positive 32. And for the J, we've got 0 minus 32, and that's a minus, so that gives us positive 32. And then for K, we've got 0 minus a negative 32, gives us another positive 32. So this now is giving us our cross product for it. But to simplify for this equation, actually the normal vector, we can simply do as a without the 32 units on there. So this easily simplifies down to just 1, 1, 1. So coming up with our equation for the plane, we're going to have 1 x minus plus 1 y minus plus 1 z minus equals 0. So then at these points we can plug in any one of these, but I'll go ahead and use P. So it's x minus 4, y minus 4, and z plus 1. So all we have to do is add the 4's to both sides, subtract a 1. That gives us our equation of the plane, x plus y plus z equals 7. And that's our answer to the A question. Gives us our first part. Now the B question is asking for the area of a triangle based on these 3 points. Now, if we take the cross product and do a magnitude on it, that would give us the area of what the parallelogram would be among the 3 points. So we'll start with that formula, the magnitude of U crossed with V for a parallelogram, but really to do a triangle we just need half of that, which then this is going to come down to 1/2 times the square root of 32 squared plus 32 squared plus 32 squared, which then that simplifies down to 1/2 32 squared times 3 times, which then that simplifies down to, that would be 32. 32 halves is 16 root 3. So that then is the answer to our B question. And finally then C asks for the angle between PQ and PR. Using the definition of the dot product, we have the formula that cosine of theta equals the dot product U dot V over the magnitude of U times the magnitude of V. So we plug in the 2 points. The dot product is easier to figure, and then we need to do the magnitude. So with this then, we've got our vector 0, -8, +8, dot 4, -4, 0. Now this is going to be over the magnitude. These magnitudes are similar in that they've got the same value. We're just talking about square root of 8 squared plus 8 squared equals 8 root 2. Same with this. It's going to be 4 root 2. 8 root 2. Okay, so this then simplifies with 0 times 4. -8 times -4, that becomes 32. And 0 times 8, 0. We've got 8 times 4 is 32. And we've got root 2 times square root of 2, which is times 2. So that cancels down simply to 1/2. Now remembering from trigonometry, we need to come up with the cosine theta of 1/2. So using our unit circle here, where cosine is 1/2, we're at pi over 3. So that gives us our theta equals pi over 3. And that's the answer to our C question. So that gives us our A, B is over here, and C.